All right, here's the 2014 NCEA 2 calculus exam. Question 2F. This one says the tangent to a graph of the function blah at the point where x is 3 passes through the point 0, 4. And they really do need to leave a comma, space after the comma, yeah? So it should be 0, space 4. Anyway, so it's got this thing here. It says there is a function and there's a tangent to this function. And it happens to be where x is 3. And it passes through the point 0, 4. So this means that if I was to draw this up more or less, if this was my y-axis, we've got point 0 along, 4 up. I'm going to call this point here 0, 4. There's my 0, 4. Yeah, there it is. And we've got a tangent there. So let's say the tangent looks like this. Yeah, and it intersects with this at where x is 3. So let's say x is 3 is, well, let's say there's an x-axis here, and let's say there's an x equals 3, let's say along here. That's my x is 3 line, x equals 3. And let's say the tangent, it might happen like this. Yeah, there might be a parabola that goes through like this and touches there. Could be there, or it could be on the other end here. It could be upside down like here. It also might be, this might actually also head downwards. This might actually go down like this, yeah? And it might actually be like over here like this. Or it could be like over here like this, yeah? We don't really know, but we do know there's a line that passes through 0, 4. There it is. And it intersects with a function, this function here, when x is 3. So it seems to me that the key to solving this is really to go for this tangent here. So we've got this thing and we're going to use this, but this is really just so we can find the tangent. So, well, the equation of the tangent is surely going to have to be, in fact, I can write actually y minus y1 is equal to m x, well, not two m's, x minus x1, yeah? So it's going to be x minus x1. I'm spreading it out nicely so I can fit things in, because I can see these are not just going to be individual values to the start with. They're probably going to be actual equations, or at least some sort of term. So we're going to probably end up writing expressions in here because we don't have actual, well, we do actually have some values, actually. That's not quite true. In fact, I can write some stuff in immediately. I can see, well, we've got a value for y. Well, y is going to be a 4. I can actually put that in here. Here's a 4. So I've got a 4 here. I don't know what y1 is. We don't have an m, but we've got an x. X is going to be, so it's going to be m, and this is going to be a 0, minus an x1. Well, that's going to be my 3. So we've got a 3 in there. So I just really need to come up with an expression for y1 and m. Well, here's y. Let's write that in there. So I've got y is equal to px squared plus 4x minus 5. And we have a value, of course. We know it's going to pass through x is 3. So that must pass through this. So I'm going to say let x equals 3. So therefore y is equal to p times 3 squared plus 4 times 3 minus 5. So therefore y is equal to, well, 3 squared is 9. That's 9p plus 4 3s are 12 minus 5 is 7. So there is an expression, or an equation in this case, or value for y. Y is 9p plus 7. Well, let's actually write this in here. So rather than a y1 there, let's actually go ahead and write in that space, here it is, 9p plus 7. I'll pop it in brackets as well. Now we just need one for m, but we can find m because we've got an equation here. We're just going to differentiate this, and we're going to end up with a value for m. So let's do that. So y is px squared plus 4x minus 5. dy dx, in other words, we could say that's the gradient. That's going to be 2px plus 4. Does that work? Yeah, I think that's good. So we can say m is equal to that, because this is m. And of course, we've got a value for x. Value for x was 3. There it is. So it's going to be 2 times 3, 2 times 3p plus 4. So m is equal to 6p plus 4. There it is. So let's pop that straight in as well. So I'm going to get rid of the m here and just make that 6p plus 4. All right, now we've got rid of the y's, the m's, and the x's. All we've got is left is p. So now let's solve for p. Here we go. So it's going to be 4 minus 9p minus 7, because minus that and minus that, is equal to, that's a 7 by the way, this is going to be negative 3 times 6p plus 4. Let's just tidy this up. 4 minus 7 is minus 3, minus 9p is equal to, negative 3 times 6 is going to be negative 18p plus, or minus 3 times positive 4 is minus 12. All right, so what do we got? Let's add 9p to both sides. Add 9p. Add 9p. So 9p minus 9p is 0. We're going to, a negative 3 is equal to 9p plus negative 18p is negative 9p plus, or rather minus 12. I've still got minus 12 here. But I'm going to add 12. I'm going to add 12 to both sides. I'm going to add 12 to this side. 12 minus 3 is going to be 9. So 9 is equal to negative 9p. So p must equal negative 1. There's my value for p. All right, now let's go back to the equation. So it says find the value of p, check, and hence the value of the tangent. Well, the tangent is this thing here. Let's go back and fix up the tangent. So here it is. We've got y minus y1 is equal to m x minus x1. All right, so what do we got here? We've got y minus and y1. Well, I'm going to use 0 and 4 again here. So y is going to be 4. Here it is equal to m. And what's m going to be? M is, well, we know p now, so m is equal to 6 times negative 1, because p was negative 1, yeah, plus 4. So negative is equal to negative 6 plus 4. M is equal to negative 2. There it is. So I'm going to have a negative 2 brackets x minus x1, and x1 was 0. There it is. And the reason I'm using that is because they're the points through which this thing travels. In other words, to use the point gradient, you've got to have a point and a gradient. Well, we've got our point, it's negative 4 and 0, or 0 comma negative 4, and our gradient is negative 2. So that's how we're doing this. So let's go ahead. And so y minus 4 is equal to negative 2x, adding 4 to both sides. Y is equal to negative 2x plus 4. And there is my solution. So p was equal to negative 1, and y was equal to negative 2x plus 4. And that's how I would find the answer.